The second biasing circuit is the collector feedback resistor biasing. One of the ways to improve the biasability is to obtain the base bias voltage from the collector of the transistor instead of from collector supply voltage. In fixed bias, we are taking the base current from the supply voltage VCC. Here in this collector feedback resistor biasing, we are taking the base current from the collector resistance. In this common emitter configuration, that is here the emitter and base is given, input is given between emitter and base. This is the emitter and this is the base, and the collector is connected to plus VCC. Here IB, the base current, zero signal base current is provided from the collector. That means a feedback circuit RB is connected from the collector to base. This is RB and this is the base current, and this voltage, that is this much voltage is the VB, that is the base emitter voltage. Here the voltage across RC, that is VCB, collector to base voltage, this provides the corresponding base current IB. Here the zero signal base current is provided by the collector base voltage, that is this much, the collector to base voltage, and not VCC. So this collector to base voltage forward biases the emitter base junction. That means this collector base voltage is applying the necessary zero signal IB current for the proper working. Let's go for the circuit analysis. Here, considering this mesh, that is this is the supply voltage VCC. VCC is dropped across the collector resistor as IC into RC. Then IB into RB as the voltage across the base resistor, and the base emitter voltage, that is VCC is equal to, we can write the Kirchhoff's equation as VCC is equal to ICRC plus IBRB plus the base emitter voltage VBE. So from that we can, now RB is equal to VCC minus ICRC minus VBE divided by IB, that is VCC minus ICRC minus VBE the whole divided by IB. But we have IC is equal to beta times IB. From that RB is equal to VCC minus beta times IB RC minus VBE the whole divided by IB. We can go for an alternative method also. That is VCE, that is the collector emitter voltage. VCE is equal to VBE plus VCB base. This is the collector emitter voltage, this much from here to here. This much is the collector emitter voltage. This voltage is equal to VCB. VCB means it is the collector base voltage plus VBE, that is the base emitter voltage. So VCE is equal to VCB plus VBE. That means we can write this as VCE, that is the collector emitter voltage is supplying the necessary biasing voltage. So VBE plus VCB. That is, we can write VCB as VCE minus VBE. Since VBE is very much small, we can write VCB is equal to VCE. VCB is equal to VCE minus VBE, or RB is equal to VCB divided by IB. VCB is the collector base voltage. VCB means IBRB. So VCB is equal to IBRB, and from that RB is equal to VCB by IB.